All right, let's get to the most loved and most hated part of the kit. The full color TFT touchscreen. These are loved because they are cheap. They're extremely useful. It instantly snaps into your Arduino Uno board. Oh, look at that. Oh yeah. And it adds an immediate touch of professionalism. They're hated because there is a lot of confusion out there as to how to even use these boards. A variety of manufacturers make identical looking boards that have different driver chips, and thus there is no cross compatibility between the sketches. And there seems to be a lot of contradictory information on the internet over all these boards. Some people get them working, others don't. So I'm here to hopefully dispel a lot of the confusion and mystery, as even I struggled to wade through everything and beat these boards into submission to get them to do what I wanted. Now, I personally love them as they are so cheap and readily available. You can get them for as cheap as like $3. So they have at least a 240 by 320 pixel display, and each pixel can display over 262,000 different colors, and it's got a touch screen built in. What more could you ask for in your projects? So let's break it down and start by keeping it simple. Unfortunately, the biggest source of confusion has been the many different kind of driver chips for the screens that are available on identical looking boards. Usually you can go to your manufacturer and they'll tell you which driver chips you got. But even that's not consistent. Here, check this out. This is the board that I distributed in the kits that I sell. It was designed by MCU Friend, and when you go to the website and find the board, they give you, basic info, but even here they have 2 different drivers listed for this board. So which one do you have? Adafruit, SparkFun, and others also made boards that at first glance look identical to this board, but yet they use different driver chips still. And here's the catch. You can't just look at the numbers on the chips on the board to figure out which driver chips you got. Why? Because the driver chips were constructed using an amazing technology called chip on glass. That's right, the driver chips are etched right onto one of the layers of glass in the screen. There are no numbers to go and look at. This flat connector of dozens and dozens of connections is actually connected to the driver chips. These chips on the back of the board, those are simply buffers, or basically amplifier chips, connecting the touch screen or functions on the board with the connecting pins. You can't identify the driver chips by those because they have nothing to do with how the board is controlled. Now, fortunately, or unfortunately, because this can lead to a lot of confusion, once one driver chipset was manufactured, other chipsets tended to follow the convention of that original chipset. So the instructions from one chipset can still work on a completely different chipset. This gets really confusing though, because sometimes one chipset will have registers that don't even exist on another chipset. Or the 2 chipsets have the same register for the same function at the same address, but the register bits are set differently between the 2 chipsets. So this is why some have reported a working screen with the libraries that are out there, but the screen is like backwards or sideways. Furthermore, several of the different settings or functions of the chipset are actually set by physically soldering certain wires on the chip. So this is obviously done by the manufacturer of the shield itself, and you have no say in the matter. For instance, normally this board is 240 pixels wide, 320 pixels tall. So it's a portrait mode screen with pixel 0,0 up here in the upper left corner. Some displays, like this one, are 480 pixels wide by 320 pixels high. And that's been hardwired on this particular board. So it's landscape mode by default with pixel 0,0 up here. So the first and most important thing you need to figure out is what driver chips you have on your TFT display. So how do you find this out? Well, the chip manufacturers permanently put the identification number in ROM memory on board the chips. So you can read a specific address on the board and it'll spit out an ID. And thus we run into our first problem. You have to communicate with the board, wire it up to your Arduino, and in order to even find out how to drive it. So for those of you who got the digital electronics kit, and probably the majority of you out there who sourced your own parts, you have a board that just snaps into the Arduino Uno connections. Boom, done deal. Now be careful though. Notice this big, ugly chunk of metal covering the USB port. It touches the back of your TFT display, so it can short out any exposed connections there. Now, most manufacturers have taken this into account, and there are no exposed connections on the back of the TFT display here. But to be safe, just stick a piece of insulating tape of some kind on the USB port metal case. Any tape will do. So some of you may have gotten a board with connections like this one. A quick look at the labels for the pins will tell you a lot about how to communicate with your board. This one is a serial connection, probably SPI or I2C. You're on your own for figuring out the communication on those, I'm afraid, as I'll be focusing on the boards and the kits that have the parallel bus. So if you look at the back of these boards, you'll probably even recognize some of the labels. And thus you can probably quickly figure out how to run the board just by your experience and knowledge. So look at this, data lines D0 through D7. And over on this side, you'll recognize control pins with an awful lot of similarity to the Hitachi board. Reset, chip select, register select, write and read. So your brain gears may be already turning. Presuming that these pins follow the convention, and they do, then the control pins will all probably be active low pins. And we just send our data to the data pins, hold the RS line low if it's an instruction, or high if it's data, and then pulse the right line with a low pulse. And that's it, easy peasy. The question, of course, now becomes just what data do you put on the data bus? Now we'll get to that in a minute. We first need to figure out which driver chips your board has in order to figure out what data we need to send. Fortunately, several people have very kindly put together a very little sketch that will show you the driver chip ID. You'll need to install the libraries. So in your Arduino IDE, go to Sketch, include Library, Library Manager. And once it's populated, in the search box, type in MCU friend, and it should be the very first library listed. Click on More Info and install the most recent version. Now, go to File, Examples, and way down at the bottom, you'll see the MCU friend flyout. Look for LCD ID read reg and open it. This sketch will read all the pertinent ID registers and spit them out in the serial monitor. So with your Shield plugged in, upload that sketch to and open the serial monitor. Serial monitor. It will spit out the contents of a bunch of different registers. So reading the register contents is somewhat subject to interpretation and guesswork. Let's take a look at a couple of readouts of some mystery boards. Many chips hold their ID right at address 0. Other chips hold their ID information in multiple bytes in multiple addresses. For instance, this one is the ILI 9325, and the ID happens to be stored in the first register. This is the way it was originally done, but it's been a long time since I've seen one like this. This is the best case scenario. The ID is in the first register. All the other ID registers are zeros. Easy peasy. This one is a 9302. This ID happens to be stored at address 04, but this one is still clear as day. It's got the chip ID in the register that's supposed to be the manufacturer's ID, but it's also got the chip ID down here where the company ILI Tech usually puts their chip IDs. These other registers, like the power mode or the pixel format, are initialization registers, not ID registers, so we just ignore those. The ID registers have a specific number in them, like this one, while all the other ID registers are zeros. If you got a kit from me, there's a good chance this will be your readout. This is the 9341, and you can see the ID down here in register D3. Now, as you saw, even though I was sure to consistently source the shields for my kits from the same supplier, the manufacturer often changes the chips on the same board. So if you got your TFT display in a kit from me, there's a possibility this is the readout you will get. It's strange that instead of zeros in all the empty registers, it tends to have 60, 60. Until you scroll all the way down here to the ID entry for the ILI series, there is no ILI 7169. However, I happen to know that this board at least works with the ILI 9341 instructions, and the 9341 was claimed to be the driver for these boards. So I will be specifically driving the ILI 9341 in this lesson, and you'll have to figure out which chipset you have, find the data sheet for it, and figure out what changes, if any, that you'll need to make to the instructions you sent. If you do not know or cannot figure out which board is yours, just try other common drivers. Because the later chips copied the earlier ones, they tend to follow the same conventions. For example, the Samsung S6D04H0X is nearly identical to the ILI Tech 9341. In fact, the majority of the driver chips out there use the exact same instruction set as the 9341. So if you don't know what driver chips you have, start by assuming it's a 9341 convention, and then use that data sheet, which is available in the download section. Other likely conventions might be the ILI 9320 or the 9325 or the ILI 7783. Now, before we move on, when you plug your board in and flash the Arduino with the read register sketch, look at your screen and see what it does. Some screens go completely white, like this one. Others go completely black, or maybe yours is an oddball and does something different. It doesn't matter. Just make a mental note of what your screen does during this time, because your screen has just been powered up, and this is what it looks like when it's in default mode on power up with the screen disabled. You'll need this information in the next lesson. Now, as if that wasn't confusing enough, take a look at the flip side of the board. You'll see that the data lines are kind of weird. It goes D0, D1, then D2 through D7 are up here. It would be nice if we could just write our byte to a port and have that port connected to the data bus instead of having to write ones and zeros to individual pins. So when you take a look at the ports on the Arduino Uno, you'll see that they could have done this and hooked up the data bus to port D. Instead, they split up the data bus in a very weird way. As a result, this adds a whole pile of complexity and confusion to our code, and as a result, when the display doesn't work properly, it might be the wiring, it might be incorrect configuration of registers, or it could be our program. Now, there are reasons they made the boards this way, but to greatly simplify our program while we get it up and running, I'm going to connect my TFT display to the Arduino with jumper wires. Now, you may not have enough jumpers to do this. You can connect some wires with just male to female jumpers, and then daisy chain male to male and female to female jumpers to make more female to male jumpers. Or you can also plug your display onto your breadboard and jump the connections using wires. Now, unfortunately, because the pins are made to be compatible with the Arduino Uno standard board, the pins don't all fit on a breadboard. Now, this side, the control pins and power, those will plug into a breadboard. and then you can connect each pin with a wire to jumper over to your Arduino board. I'm connecting the data lines to their corresponding digital input-output lines on the Arduino. So D0 will go to pin 0, D1 will go to pin 1, D2 will go to pin 2, etc. Then I'll hook up power and control lines as such, and this wiring diagram is available in the downloads section. Do you remember the ports on our PICs? We've been writing to individual pins on the Arduino, but the Arduino is exactly like the PIC in that we've been writing to individual bits on one of the ports. So when we performed a digital write command, it was in effect just like writing that bit set command on the PIC. So for convenience, we can write 8 bits at once by simply writing a byte to a port. Now, unfortunately, the particular PIC that's in our kits does not have an 8-bit port. If you'll recall, port A only had A0, A1, A3, A4, and A5. Port C only had bits 0 through 5. The Arduino, like the PIC, has ports, 3 of them in this case. Port C has bits 0 through 5, so it doesn't have 8 bits. Port B has bits 0 through 6, still not 8 bits. But port D does have 8 bits. So this is why I connected pins 0 through 7 to data pins 0 through 7 on your TFT display, because the Arduino pins 0 through 7 conveniently correspond to port D's bits 0 through 7. There is one caveat I have to mention. When using all of the bits on port D, it includes pins 0 and 1. You'll notice those are the serial connections, TX and RX. Those 2 pins are directly connected to the USB port on the board. So if you have any circuitry hooked up to these, it will most likely mess up your connection to your computer, so you can't upload your sketch to the board, nor can you use the serial monitor. So to upload your sketch, you'll have to unplug these 2 wires while you flash it. Once the sketch is uploaded, you can then reconnect those 2 pins and then just reset the board so it starts running the sketch at the beginning. But aside from that inconvenience, we can now just directly write our 8-bit data straight to port D, and it will arrive on the data bus on our TFT display. And as you'll see in the next lesson, this simplifies things tremendously.